So question 18, we know the straight line needs to be perpendicular to this one. So the gradient of this line at the moment is, remember, the number in front of x, which is 4. So this gradient is 4. And if the question said it needs to be parallel to it, then we would keep the gradient as 4. But actually this is perpendicular. So therefore I need to do 1 over it. And because that one is positive, I would make this one negative. So it's up to you whether you put it on the 1 or the 4. So I'm going to put the negative there on the 1. So then we know it goes through 0, 6. So putting both of these into y minus y1, it would be y take away y1, which is 6, equals minus a quarter, and then it would be x minus x1, which is 0. So I'm going to times by 4, and both of those get times by 4, so 4y minus 24. And that then just gets rid of the 4 on this side, so I just need to do minus 1 times x, which is minus x, and then that one is just going to be 0. So we need to get it into this form, y equals mx plus c. So to get rid of minus 24, I'm going to add 24. And then I divide by 4 to get that. So writing it in this form, that there is technically a 1. So it would be y equals minus 1 over x over 4, minus 1x over 4, and then 24 over 4 is 6. So it would be minus a quarter x and then plus 6. Part B is working out the coordinates of the intersection. So if this is equal to y and this is also equal to y, then the point where they intersect, they must be equal to each other. So you start by just making one equation equal the other. So 4x minus 5 equals x squared minus 17. And whenever you've got an equation like this with x squared in, you want to make it equal 0, and you want to try and keep the x squared term positive. So therefore I would keep everything over this side and get rid of the things on this side. So to get rid of minus 5, the opposite is to add 5. So when I add 5, I'm going to get x squared, and minus 17 add 5 is minus 12. After that, I want to get rid of the 4x here, so I'm going to minus 4x from both sides. So I'm going to get 0 here, and then this side I would get x squared minus 12 minus 4x. Now it makes more sense to put the x in the middle, because as soon as you see that, then you are very used to seeing things like this, and that is where we factorise that now into 2 brackets. So I would find numbers that multiply to get 12 that you can make minus 4 from, which is minus 6 and plus 2. So therefore the two values of x are positive 6 or x equals minus 2. So those are going to be the x values. We now need to work out the y values, and to do that you put your x values back into one of the original equations. So I'm going to go for this one, where we times it by 4 and then take away 5. So if x is 6, if I times that by 4 and take away 5, times by 4 is 24, take away 5 is 19. This one times by 4 is minus 8, take away 5 is then minus 13. So my two coordinates are 6, 19, and then minus 2, minus 13. So question 19 is drawing a histogram. So we have done this fairly recently in class. However, I'm just going to do this the way I would approach this in an exam. So a table like this, remember we said you get mad. Maths is challenging, or challenging and hard, whichever way you like to remember it. So remember, it goes mean, cumulative frequency, histogram. So we're looking at this one, which is the D. So D stands for divide. And you're dividing by the difference, which also begins with D. You're dividing by the difference between each of these. So that's a difference of 10, 10, 20, and then a difference of 40. So if we work these out, so 54 divided by 10 is 5.4. 50 divided by 10 is 5. 44 divided by 20, well, if I do 44 divided by 2, that's 22. So therefore if I divide it by 20, it's going to be 10 times smaller than that, so 2.2 and then 20 divided by 40 is 0.5. So in terms of drawing this on here, I'm not going to do every single bar. I'm just going to do a couple. So the first one goes from 0 to 10, and I want to go up to the frequency density, not the frequency. Otherwise there would have been no point working those out. So on this axis here, it should be frequency density, and the highest frequency density is 5.4. So I'm going to make sure I go up high enough. So I'm going to go up in ones on the big squares like that. And I now need to plot these like a bar chart. So the first one is between 0 and 10, and it goes up to 5.4. So 5.4 would be here. Ideally, you should be using a ruler, but I don't have one on me right now. So that would be my first bar, drawn nicely with a ruler. The next one is between 10 and 20, and it goes up to 5. So that is going to go across there. And then down like that. And then you would complete it now. The next one would be 20 to 40 and up to 2.2. So it would be coming out over here. Sorry, you can't see that. There we go. Coming out over here and down like that. And then the last one is a wider bar, again, from 40 to 80. And it only goes up to 0.5. So that would be going along there like that. So part B, so Kerry says the longest time that any of these students took to travel to school was 80 minutes. Is she correct? Well, we know that the largest group is between 40 and 80. We don't know exactly what those 20 times were, however. They could be anywhere within that group, so we don't know the exact values. So therefore it could be that all 20 values are, for example, 60, or they could all be 70. It could be a mixture. It could be like 40, 50, and then the rest are 60. It doesn't necessarily go right up to 80. So is she correct? Give her a reason for her answer. I would say something along the lines of not necessarily. I mean, she could be correct, but it's not necessarily correct, because of the fact we know that they are somewhere in that group, but we don't know the exact values, and they could be anywhere within the 40 to 80 group. Part C, she also claims that 25% of all the students at this academy took more than 30 minutes to travel to school. We've got to show how she might have worked out her claim. So more than 30 minutes. 30 minutes would be from here. So it's half of this group, and then all of this group here are all bigger than 30. So all of that group would be 20, and then it would be half of that group. So half of 44 is 22. So 22 plus 20 is 42. So ideally we want to be showing this, so I probably should have written this a bit more clearly. So that is between 30 and 40, and then this one was between 40 and 80. So that is 42 out of 168. So that's pretty horrible to change that into a percentage. So what can we do with that? We could half them both to get 21 over 84. And then we can divide these by 7 to get 3 over 12. Divide this by 3 to get a quarter, and a quarter is 25%, so therefore that's how she would have worked out that claim. So the assumption that we've made is the fact that when we split this group here, we're assuming that half of them are above 30 and half of them are below 30, and it might actually be that they're all between 20 and 30, so we're just assuming that they're equally spread out in that group, and therefore we've taken half of it to be above 30. So that is that question. And the final question, on question 20, this is quite a tricky question, especially part 2, but part 1 and B should be okay. So we need to find the value of k when n equals 7. So if n is 7, that means we're trying to work out root 2 to the power of 7. So because the power is fairly small, I would probably just write this out as root 2 times by itself 7 times. So 1, 2, 3, 4, 5, 6, 7. So in terms of that now, we know root 2 times root 2 is 2. And that's going to make another 2. And that's going to be another 2. So that makes 2 times 2 times 2 times root 2. And 2 times 2 times 2 is 8. So it's 8 root 2. So therefore k is just the number in front, which is the 8. Right. The next one is the one that is a little trickier. So we know that k is 64. So we know root 2 to the power of n is 64 root 2. So we're trying to work out what this power here of n must be in order to make the answer 64 root 2. So first of all, I would think about what this is as a power of 2. So 64 is 2 to the power of 6, isn't it? So 2 to the power of 6 times by root 2. So then we said up here that to make 2, it's root 2 times root 2. So for every one of these 2's, I would need to have 2 root 2's, because when a root 2 times by itself, you then get the 2. So if it helps, you don't necessarily have to write this down, but I'm just going to show you. So if I've got 6 2's here times together, like that, times then the final root 2. So for every one of these, I would need a root 2 times root 2. So if I count that up for each one of those, that would be 2 for this one, then 4, 6, 8, 10, 12, plus I've got this extra root 2 here. So that's going to make root 2 to the power of 13. So n is therefore 13. And the final question then is rationalising the denominator. So I'm just going to rewrite the question. So when you've got something like this, you times by what's on the bottom, but you change the sign. So this one is a minus, so I need to change it to 3 plus root 2, and I'm going to do the same to the top as well. So when I do 14 times 3, I get 42, and 14 times root 2 is 14 root 2. And then the bottom bit I'd put into brackets like this, and expand it however you expand double brackets, so whether you use foil or a grid. So 3 times 3 is 9, 3 times root 2 is 3 root 2. Then I'm going to get minus root 2 times 3, so that's minus 3 root 2, and you'll notice they cancel, which should always happen. And then root 2 or minus root 2 times root 2 is minus 2. So the middle bits here cancel out, and I've just got 9 minus 2, which is 7. And so 42 divided by 7 is 6. 14 divided by 7 is 2, so it would be 6 plus 2 root 2. So that should be the final answer, because it's now in that form like that.